Okay. So we need to standardize your titrant, right? Common sense. So you're going to standardize against a primary standard. So a practical example is the NaOH. Okay, the NaOH you prepare for 0.1 molar, but you want that concentration accurately. So your NaOH now will be standardized against KHP, okay, with that particular molecular weight. So this is the reaction. So is the number of moles that have reacted, will relate to each other based on the number of moles. So as an example here, so this is going to be very similar to your today's experiment. So you weigh by difference, then dissolve. Okay, then you perform the titration. So you add NaOH into that solution. Then let's say the endpoint is reached after adding this quantity. Okay, from the equation indicates is 1-to-1 mole relationship. So now follow the keywords, number of moles relay. Okay, so MV is the number of moles. And the number of moles relationship 1-to-1. So MV, number of moles of number of millimoles of sodium hydroxide is equal to this multiplied that, right? So MV, then is equal to number of moles of NaOH equal number of moles 1-to-1. So the algebra equal to number of grams of the KHP used multiply the conversion factor molecular weight of KHP. So this is how you set up. Okay. So this is a known quantity, which is 0.4104 right here. So this is fixed. This is only unknown you are solving for, right? So this is standardized now. Okay. Any question? So your homework will be that.
Is this due on the day of the exam too, or after?
A week. Next Wednesday is exam day, right?
Could you go back one slide real quick? Could you go back that slide?
Back one slide. Oh, yeah, so much problem. No, just kidding. See, I don't have a remote, If I have the remote, then it's just a fact deal. Let's see.
Current slide.
Yeah, you go.
From current slide.
From current slide.
Right next to from beginning.
Right next to where?
From beginning, way on the left.
Way to the left.
Yeah.
Right.
Yep. Yeah.
No, from the beginning.
Right,
No,
next
no,
to
right.
it. Next to it.
Underneath home.
Oh, from current.
Yeah.
Yeah, thank you. Right here. Huh?
Yeah,
Yeah, they needed to see the home.
Oh. Is it it?
Yeah.
Oh, okay. I thought, how come I, repeat the same slide every year? Yeah.
So your whole goal in this is to figure out how many moles of KHP.
Well, this procedure is standardization for your titrant. So-called standardization is to get the accurate concentration of your titrant. Yeah.
So when is the homework due? Is this due on the same day as the exam? Or is it due the following Monday?
Because you're going to ignore this until the exam is over, right?
Yeah.
The SNFA. So let's postpone it to
Monday.
Monday after.
Okay, concentration of titrant. So in this case, the NaOH, is that what we're doing?
Right, right.
Okay.
Uh-huh. So at first, you just prepare the NaOH for approximately 0.1 molar.
Okay.
And you want to know that concentration accurately. And therefore, you titrate against your primary chemical, the KHP. Yeah. So, another question? Okay. Okay, for acid and base titration, now if we monitor the history, then we can see the curve, right? Otherwise, we only see the color change, colorless or pink colorless. So if you monitor the titration curve, then the curve will have an inflection point. So things like this. Okay, you add hydroxide to acid. Then here is the pH. Okay, so because your sample is acid to begin with, the pH will be less than 7, right? So it's going to go like this. And then you have excess hydroxide, then that is alkaline. So here is your endpoint. So here we'll read the milliliter of hydroxide added. So you know the molarity of the hydroxide. So the MV will allow you to calculate for number of millimoles, right, at the endpoint. Okay, so now the second point, strong acid versus strong base. So this strong base and this strong acid, then you're going to have a very strong so-called sharp is this spread. So let's say a Y spread for before and after the endpoint, then this is so-called, you get a sharp endpoint, okay, a large spread. So for strong acid and strong base, it's fairly large. Okay, then we will learn later on how to calculate for this curve. Okay, well, this is visible to you, but for history, but we can calculate the individual point. Okay, then sharpness depends on concentration. Okay, so this is a general look for this titration curve. In terms of concentration, well, one curve go like this, another curve go like that, another curve go like that. So as you can imagine, so this concentration, okay, let's say 0.1 molar, 0.2 molar, 0.3 molar. So after the endpoint, you're going to add excess, a volume of excess sodium hydroxide. So the little excess sodium hydroxide will elevate this end of the titration curve. So a more concentrated solution will elevate more, right? Make it a larger difference. So your assignment will be like this, okay? There's a lower concentration, and that is the highest concentration. Okay, any question? Okay, another point is, for strong acid and strong base, the endpoint pH is always, okay, always pH equal to 7.
So is the endpoint, is that just where it's just completely
in the middle of the curve. Yeah, so let's look at it with one curve. Strong acid, strong base, then you go to the middle and correspond to a reading of 7 right there. Okay, so for example, HCl and sodium hydroxide. Okay. So react with each other. The equivalence point. Now, equivalence point, what you have, right? So this is equivalence point. So you have water and this chemical. Will this chemical contribute to the pH? Well, let's do this. Okay, now when the acid, the inherent acidity is high, then the inherent basicity is low. So now we are talking about the conjugate pair. HCl, Cl minus. So remember, look at the anion. Now we realize that the HCl is very strong. Then the Cl as a base, the base would be very weak. Okay? And therefore, if you look at enough significant figure, okay, 7 point hypothetical, 0, 1, 2, 5, hypothetical example. So indeed, this solution is slightly, very slightly alkaline because this is a base. This is your final mixture product, okay? So this is your base. So contribution will be a little bit alkaline.
But the equivalence point is the same thing as the endpoint?
No. The point was made that endpoint is through observation, experimental, practical, you see color change. The equivalent point is per calculation. The coefficient call for 1 to 1, so when you add enough 1 to 1, then that's the equivalence point. Okay.